I'm Anil Kumar. Welcome to my series on sequences and series. In this video, we'll talk about a very important example, and from there, we'll also understand the concept of infinite geometric series. The question here is, find the sum of infinite series 2 plus 1 plus half plus 1 over 4 plus 1 over 8 and so on. You can always pause the video, answer the question, and then look into my suggestions. Now, in this series, what we notice is that the series could be written as 2, and then the next term here is basically 2 times half, right? So that is how you get 1, and the next number half is you have to further divide this number, the previous number, by 2 or multiply by half, right? So that is how the series is extended, right? So in this series, what we notice is that the first term, we can say A1 is 2, and since we are multiplying every time by half, the geometric series it becomes where R is equals to 1 over 2. You also notice that R is less than 1, correct? So the absolute value of R, which we are more interested in, is basically less than 1. So that means the series converges. Since the series converges, we should have a finite value of sum, correct? So that is one very important part. Now the question here is, how do we figure out what is that sum, right? You know the formula for geometric series, which is S of n is equal to the first term times 1 minus r to the power of n over 1 minus r. Now this is a general formula which all of you know. We are going to see what happens to this formula when n approaches infinity, right? So in infinite series, we know this n is actually approaching to infinite terms, right? So in that case, let us first derive the formula, then we'll apply. So in that case, S of n, we are finding a limit, let's write limit, when n approaches infinitely large value. So in that case, we have this limit when n approaches infinitely large value for a times 1 minus r to the power of n over 1 minus r. Now in that case, r is less than 1, and therefore r to the power of n will be smaller as n approaches infinity. R to the power of n approaches 0. Is that clear to you? Right. So what we notice here is r to the power of n approaches 0 as n is very, very large, since r is less than 1, right? So therefore, for infinite geometric series, the sum of infinite terms, we can write like this, will basically be a times 1 minus 0 over 1 minus r, since r to the power of n approaches 0. You get the idea. And therefore, we get our formula for infinite series, which is basically very simple, a over 1 minus r. Is that clear to you? So that becomes your formula. Now, once you know the formula, you could directly apply this. This is an infinite series where you know that the first term here is 2, the r value is 1 over 2. So applying this formula, we can find sum of this series as equal to, first term is 2 divided by 1 minus half. That is the value of r, right? So that should be equal to 2 over 2 minus 1 over 2. So that is equal to, let me write here, 2 times 2, right? Or equal to 4. So sum of this series is 4, right? So our answer here is 4. Is that clear to you? So that is how you could actually solve this question. If you know the formula, just apply it directly and it's just a minute, less than a minute, then you can get your answer. Now, for the same question, let's have a geometrical representation. Understanding, let's say, right? What we could consider here is that we could consider a square. Let's say here we have a square, and in this square each side is 2 units. We have a 2 by 2 square. So we have 2 by 2 square. So each side here is 2 units. Now what happens if I divide it into half? So we have a square, and if I divide it into half, then this side becomes 1, right? This remains at 2. So the area here will be 2, right? This is the area. So what we are showing here is the area of the square, right? So let's consider area of square. So when you divide it into half, you get area of 1 times 2, which is 2. Now, if I further divide it into half, then what happens? Well, the area of this portion is 2 units, then the area of that smaller portion should be 1 unit. So what we have done here is that we started with 2, right? So the area of 2, and then we added 1, so we get up to this much. You could see it like this, right? Now, if I divide this further by into 2 equal parts, I get area of half, right? So we get area of half. Now we can actually repeat this process n number of times. So dividing each time by half, and you can see that the area keeps on getting multiplied by half. So it's kind of a geometric series representation of what we had begun with, correct? So if I further divide this into half, I get here what? 1 over 8, right? So 2 plus 1 plus half plus 1 over 4 plus 1 over 8. And if we continue this process, then we are going to fill up the whole area, right? So if I continue this process till infinite divisions, we'll complete the whole area, right? So, and you can see that the whole area here is 2 by 2, right? So the total area, let me push the page a bit, right? So what you see here is that the total area is equal to 2 by 2, and that is equal to 4. So we can see that this all is equal to 4. So we can have an area model to represent our equation. Does make sense to you? So what we have here is a series. We are dividing the whole area into halves each time, right? Or multiplying by 2, or 1 over 2 multiplying by half, right? So if you do that, you're going to fill it up, and ultimately you will fill the area of 2 times 2, which is 4. And therefore we can say that the total area will be 4, and this series will be approaching a value of 4 as we take infinite terms of this particular series. Does make sense to you? This also confirms that the formula which we used here is perfectly fine, and it can help us to solve similar questions. I hope that makes sense. Feel free to write your comment, share your views, and also watch some other videos on this particular topic to get complete understanding of this topic. Thanks for your time, and all the best.